This is 4.5 integration by substitution. And go over some examples dealing with trig functions. So the general pattern is I want to identify what the inside function is, make sure the derivative of the inside is there, and then find the antiderivative of the outermost function. So in this example, I have cosine equal to this, x to the fourth plus 2, and I'm multiplying that by 3x to the third power. So hopefully by now you recognize that the inside is going to be the higher degree polynomial, so it's going to be x to the fourth plus 2, because the derivative du dx, this derivative is 4x to the third. And as far as matching up the pattern here, this is going to be my u, and x to the third dx is what I have over here once I multiply this dx over. So this over here is what I have. Now, what I don't have in the problem is this additional 4. I'm going to divide this 1/4 over. And this problem has an additional 3. So just watch how I take care of this 3. When I rewrite my integral, I'm going to keep this 3, so it's just I'm going to keep it there. Cosine, the inside part is what I let u equal, so it's cosine of u. X to the third dx, which are down over here. These two get replaced with 1/4 du. So the trick I can do is I'm going to multiply 3 and 1/4 to make it 3 over 4, and then factor that out all at once. So 3 over 4 gets factored out, and then cosine of u du. So the strategy, I guess, here is that if I have this additional 3, I can just keep it there, and once I go to factor out this 1/4, multiply them together, and then factor them out at the same time. Alright. From here, I just go ahead and apply the outermost antiderivative is the antiderivative of cosine, which is a positive sign. So my answer is going to be 3 over 4 sine of u. There are no limits, so it's indefinite, meaning that I have to put a plus c, and then put everything back in terms of x. So my answer is going to be 3 over 4 sine of x to the fourth plus 2 plus c, and there is my indefinite integral, my antiderivative, and that's my answer. For example 2, I have a definite integral, which means I have upper and lower limits. So the same strategy, I will do a u sub, 2 over 3 x, the derivative of that with respect to x is 2 over 3. Multiply the dx over, so du is equal to 2 over 3 dx. So this is going to be my u. This over here is the dx. I don't have this extra constant, so to get rid of a constant, you multiply by the reciprocal. So it's going to be 3 over 2, 3 over 2. So it's kind of what I've been doing this whole time, is multiplying by the reciprocal, so I haven't really called it that. So 3 over 2 du really is what dx is equal to. So when I go to write my integral, it's going to be cosine of u. Dx gets replaced with 3 over 2. Now I do have a limit, so I'm going to go ahead and do a limit switch. The limit switch says that you plug your lower limit into what you selected for u. So u 0 well, 0 remains 0 when I plug in into here. So u 0 remains 0, so that's going to be my lower limit. When I plug in now u of pi over 2, that's going to be 2 times 3 times pi over 2, which comes out to be pi over 3. These two reduce out, and I'm left with pi over 3. Alright, so continuing. 3 over 2, that gets factored out. My integral from 0 to pi over 3. Cosine of u du. Antiderivative we said was a sine, so it's 3 over 2 sine of u. Lower limit is 0, upper limit is pi over 3. When I go ahead and evaluate this, turn the paper up here. It's going to be 3 over 2 sine of pi over 3 minus sine of 0. Sine of 0 is in fact 0. This is sine of pi over 3 is square root of 3 over 2. I'm multiplying that by 3 over 2, which was factored out. So my answer is 3 radical 3 all over 4. My numerical value of this was 3 radical 3 all over 4. Alright, one last example. Find the antiderivative of this. Finding my antiderivative h of x is going to be integrating cosine square root of x all over square root of x dx. Now inside the cosine is square root of x, so my initial thing is for u subs is you want to let u be the inside part. So we're looking for what the inside is. So inside this cosine, I have square root of x. So I'm going to let u equal square root of x. Now I can write this as x to the 1/2, because now the derivative of that by the power rule, which is 1/2 x to the negative 1/2. If I cross multiply, it's du equal to 1 over 2 square root of x dx. And notice I have square root of x in the denominator, dx next to it, and square root of x in the denominator, dx next to it. So I can replace that with du as long as I multiply this 2 over. So 2 du is 1 over square root of x dx, which is what I have in here, and this is going to be replaced with u. So my integral turns out to be cosine of u square root of x in the denominator and dx get replaced with 2 du. Choose a constant, factors out. So I have cosine of u du. And then from there it's going to be 2 antiderivative of cosine, which we've done 3 times now, is sine of u. It's indefinite, so it's going to be a plus c. And then go back to initially what u was equal to. So it's 2 sine of square root of x plus c. And that's it.